Right, so now we've spent a lot of lab time working with and analyzing and just dealing with multispectral or aerial or satellite imagery. We're going to now shift gears to dealing with digital elevation data. In this first lab, we're going to focus on creating terrain derivatives from DEMs or digital elevation models or digital terrain models, DTMs. Note we've provided some links here to some useful videos. Most of this work can be accomplished using tools in the surface toolbox. So for example, calculating like slope or aspect, or doing local focal statistics, and using raster calculator. So there's some links there. So you're going to answer some general questions about digital terrain analysis and then work through some analyses and visualizing some data. So in the Seneca map, we've provided some examples already created. So here's a hill shade image of this area around Seneca Rocks, and this was derived from LiDAR, so it's a fairly detailed elevation model. So this is the original DEM, and then from that we generated a heat load index, shown here, topographic dissection index, topographic roughness, slope position, topographic aspect, slope in degrees, and then the hill shade. So you're going to answer some questions just visualizing those layers. Next, you're going to make some of your own layers, and that's going to be accomplished using one of two data sets. You don't have to do both. So we have this Preston data set, which is a DEM derived from LiDAR for a portion of Preston County, West Virginia, around the town of Rollsburg, which is around here. And then, or this Canaan Valley data. Note this Canaan Valley data is not rectangular, and there's some weird interpolation stuff on the sides, so you can just kind of ignore that. You're mainly just going to be looking at the middle. So pick one of those two data sets, and you're going to derive these different metrics for it using the methods shown in the module and demonstrated in the example videos. So a lot of this can be accomplished either using a tool. So for example, hill shade, slope, and aspect can all just be calculated using using the tools in the surface toolbox and the spatial analyst extension. To create the slope position and topographic roughness index and topographic dissection index, you're going to need to use focal operations, neighborhood analysis, and also raster calculator. In the next step, you're going to look at doing some differencing of mine features. So that's this data set. So we have two DEMs, both derived from LiDAR, one that predates some surface mining and one that was collected after the mining. So you're going to create a DEM of difference to delineate areas of cut and fill, and you're going to create a classification from that. Basically, anything between -4 and +4 meters, we're just going to assume is noise, and we're saying no change. And if it's less than -4 or greater than 0.5, then we're looking at gain or loss. And you're going to make a map layout showing that output. This last map, the Horseshoe Run map, you're not using for any analysis. We just wanted to provide some additional examples. So this is just showing some example slope failure features in the Horseshoe Run watershed, which is just north of Parsons in West Virginia. So here you can see a really large surface or slope failure. So here's the head scarp and the side scarps there, and then the failure, and then the toe. So this is just for some, and then there's some other failures out here. So this is just an example, and you don't actually have to do anything with it. It's just there for as an example.